This is an introductory video on how to go from an exponential graph, an exponential function graph, to an exponential function equation. Now, it's first just important to kind of, be able to recognize an exponential function graph in terms of the way that it kind of curves, and then also knowing the basic structure of the exponential function equation, which is y equals ab of x, and also to know what the different parts mean. So a here represents the y-intercept. So if you're at home, you might be wanting to just kind of take some little notes for yourself so you have this later on. B is the basically the base or multiplier, which is like how quickly it's growing, and then x and y are actually points. So what I like to do is when I have an exponential function graph, I like to pick a couple points, make a table so that I can kind of reference this back as I start to kind of create my equation. So I'm going to always start with just writing the basic equation down, and that shows me that I know where I'm starting. It shows whoever I'm communicating with that I know the basic structure. And as I said, A is the y-intercept, which we can pull off of the graph. We can also pull it right off the table. It's a place where x is equal to 0. So I'm going to first just plug in 3 to where A is. Now, I don't know how to find B right now, so what I'm going to do is I do know x and y are a point, so I'm going to use my other point, and I'm going to plug in for y, I'm going to plug in 6. B is an unknown, and x was a point 1, 6, so I'm going to plug that in. So 3 times b to the first power, which is just 3 times b, is equal to 6. So that must mean that b is equal to 2. So I'm going to go back, and I'm going to plug this into the equation. So now I have my equation y equals 3 for my y-intercept. My b, which I just solved, or multiplier, is 2 to the x power. And once again, go back if you don't believe it, check your 2 points. Once again, I could go back to my original point, but I would do it for both. We obviously proved it for the second one, but 2 to the 0 power, anything to the 0 power is 1, so 3 times 1 is 3. Here, 2 to the first power is 2. 2 times 3 is 6. Now let's look at the second equation here. The second graph. So here's our second graph. Once again, I've taken my graph, I've made a little table of some of the points. Start with your basic equation, y equals abx. I can see once again, A is the y-intercept, which I can get either from the table or the graph. So I'm going to start by plugging that in. I don't know what my b is, so I'm going to kind of hold off, but I do have a point. I use the same point as before. So y is 6, b is unknown, x is the value 1. So 6 equals 2 times b. So in this case, b, or the base, is 3. So going back up here, rewriting my equation with my values. 2 is the y-intercept, 3 is the base, x, and then once again I can verify with those points. So this is my equation for that graph. And you can see that the graphs, they're the same family of function. They're going to be pretty similar. Once again, that multiplier kind of shifts it up or down depending on what it is. So here's a 2, y-intercept of 2, y-intercept of 3, kind of connecting that with what the equation looks like. So here's another one, and you can see this third example looks a little bit different because the graph, I can still see that growth being exponential, but in this case it's flipped around. But I'm going to start with kind of the basic same pieces. So y equals ab to the x power. Once again, a is the y-intercept, so I can plug that value in. So y equals 4, b to the x. I'm going to plug in a point. So x is 2. X is 2. and y is 1. And so I'm like, whoa, holy moly. So I've got to think about, I can go and solve for b. So how do I solve for b? I'm going to divide both sides by 4. So 1/4 equals b squared. So what number times itself gives you 1/4? You could do it mathematically and do square root of both sides. Square root of 1. So square root of 1 is 1. Square root of 4 is 2. Or I could think about what number times itself gives you 1/4, 1/2 times 1/2. So once again, going back, plugging this into my equation. So I get y equals 4. The base is 1/2 to the x power. And once again, when you have a value for your base, if your base is greater than 0, so the base is greater than 0, but less than 1, you're going to have this kind of reverse look to your graph, okay? So if your base is greater than 1, it's going to look like this. If your base is greater than 0 but less than 1, you're going to have an inverse there on that piece. Okay, good luck with that. Once again, start always with the basic formula. Find your y-intercept, and then you can plug in a point, x and y, to solve for your base. And always check at least 2 points to make sure that it works, and you will be in good shape.